on running. How could we ever keep our society running so smoothly unless we had rolling bearings? Precision technology today allows us to manufacture the highest quality bearings designed for trouble-free operation. SKF is the world's largest manufacturer of rolling bearings. We make every part with the utmost precision. The balls are perfectly finished, and so are the rings in which they turn. And there's a thin film of lubricant everywhere in the bearing to guarantee that there's no metal-to-metal contact. So within the bearing, everything is perfectly in equilibrium. But outside, the environment threatens. There is immense heat. There's sand with the finest of abrasive dust. And there's water. All this trying to disturb the critical balance. Just a few particles of dirt or drops of water. Once they have entered a bearing, they can cause irreversible damage, destroying the special properties of the lubricant film. And so the equilibrium turns into disorder. And then you can forget all about keeping on running. So what should we do? Well, seal the bearing from damaging external threats. So, to keep on running, seal the bearing, and its life will go on and on and on and on and on and on. Seal the bearing? Just a moment. It isn't that easy after all. The operation of bearing seals is complex and mysterious. Even when one knows how they work, they look remarkable. SKF has its own engineering and research center in the Netherlands. There, one of the tasks of our renowned international team of scientists is the creation of the ultimate in rolling bearings and sealing systems. To reach this goal, we are researching the science of tribology, which combines the sciences of friction, wear, and lubrication. Let's see in close-up how a rolling bearing works. In all applications, they are essential parts of rotating components. But there will always be a very little space left between what moves and what is stationary, and that is where contamination can enter. Most seals are made of rubber. This is because rubber is highly elastic, allowing it to follow the bearing seal surface. At the same time, the seal has to show good wear resistance. The seal has to be able to withstand high temperatures and low temperatures. And still the seal has to have very low friction properties. But as we have learned, a perfect sealing is not possible with only a rubber seal. In a close-up of the cross-section of the seal, we can see the lip. With the electron microscope, large magnifications are possible. Now, the apparently smooth surface of the rubber seal lip is in fact pitted and rough. What this material roughness means, we can see on this experimental setup. As the speed of the shaft increases and there's no lubricant present under the seal lip, the friction also increases. The seal doesn't function properly because the roughness causes damage. So indeed, a rubber seal lip alone is not enough. Actually, it should work rather like an eyelid. If dirt does enter the eye, then tears wash it out. They are actually the real seal, and we can learn from nature. SKF developed seals which form a fluid film of lubricant under the seal lip. We can see that as we inject lubricant under a moving seal, it forms an extremely thin oil film, and the friction is considerably reduced. How does this function? The oil attaches itself to the seal and to the inner ring of the bearing. The roughness of the rubber helps to build up pressure. It's comparable to water skiing. Imagine the skis as the rubber seal lip and the water as the lubricant. With increasing speed, lift is created so that the skis skim over the water. This lift reduces friction and minimizes wear, but only true if at every speed there's a film of the appropriate thickness. At SKF, we have succeeded in controlling and retaining this micron-thick oil film at all speeds. But the lubricant film has more tasks. Again, as in the human eye, it should be able to keep out dangerous influences such as dirt. Experience taught us that this can be achieved through the special asymmetrical geometry of the seal lip. The special design of the lip, together with other physical effects, generates an outward pressure. It works like a pump. This pumping action is created by microscopic effects of vertical motion, lateral motion, rotational motion, and many other dynamic factors, all on a micro scale. Conclusion: control of the fluid lubricant is the real mechanism which protects the bearing. It ensures that what has to stay out really stays out. It's really all a matter of microns. In order to control the oil film, we have developed a unique method to measure the micron-thick lubricant film under the seal lip. It helps us to a better understanding of the properties of the fluid film. The measuring is done by using special transducers embedded in the shaft. One is for measuring the behavior of the film, the other to measure the under-seal lip temperature. Theoretical models have been developed to explain and predict lubricant film formation and under-lip temperatures. These are already corresponding well with experimental results. The finite element method even allows calculations of temperature distribution in the seal lip depending on speed. The refinement of the models developed is an ongoing process. So we have discovered that the principles of fluid seals are not exclusively limited to rubber seals or one fluid. In the automotive industry, this is creating possibilities for new applications. For example, water pumps with mechanical face seals. All newly developed seals are continually subjected to tests simulating all conceivable conditions. So we are sure that we can keep everything functioning. That's our job, designing efficient barriers between order and chaos. Trouble-free operation. Mission completed. We at SKF, the world's largest manufacturer of rolling bearings and sealing systems, are able to produce our products to the highest degree of precision and reliability, thanks to all the research and knowledge. So much knowledge assembled for one and the same goal, keeping on running smoothly and trouble-free. Keep on running. It's a little more complex than people think, but that's exactly the task of SKF. To create rolling bearings that keep life simple.